So we're talking about classes and objects. If you've taken other programming classes, Java, for example, C++, you probably know what a class is. And you probably know what an object is. I'll give you my shortcut little definition. A class is a blueprint for a set of data, data, if I want to pronounce it correctly. I watch too much Star Trek. Data. All right, a set of data and the functions, which are actually known as methods, that act on that data. And then the object is an instance of that class. Now that sounds all complicated, but a class is like a blueprint. Blueprint for a house, and then you build some homes, right? Build home 1, home 2, home 3. Well, now you have 3 homes. Each home is an instance of the home blueprint, right? So you had some blueprints, but you didn't have a house just because you wrote a blueprint for it. You actually had to construct them. You had to make instances of them, which is technically called instantiate. We always have to use the fanciest words possible. Instantiate. So, for example, you could have, a triangle class, and it might have some pieces of data in it. It might have a base, and it might have a height. And then that class may also have some methods that act on it. So somewhere down here, somewhere in some other piece of code, we'd have some kind of main method that would use that triangle. Triangle T1 equals new triangle, like that. And we could set the base and we could set the height. T1.base is equal to 10, T1.height is equal to 20, whatever. So we could write a method that would use those 2 pieces of information to calculate the area of the triangle. And really these, I did this last time, if you make these ints, then when it tries to do the calculation, half the time it'll come up just 0. So let's make them doubles. We have a class called triangle. It's got 2 pieces of information in it, and it's going to have a function that multiplies base times height divided by 2, because that's how you calculate the area of a triangle. So double get area, and what does it do? We're going to declare a variable to hold the result, double result. The result is equal to this dot base times this dot height divided by 2, and then return that. So when you see this, this reference like that, it means that the thing that follows is a member of the class. And it's true. Base and height are members of the class. So this is saying that a class is a group. All right. I don't know what that means. Classes are the building blocks of object-oriented programming. Now, when I said that a class is a blueprint for a collection of data, maybe that's what they mean by group. So these things like float and double and int32 are classes that came built in with C#. Any number that is declared as one of these classes can be used in arithmetic and converted into a string and so on. Similar to the wrapper classes in Java. So, types of classes. Classes that are only an application program with a main method. And then a class from which you instantiate objects. In this example, we have written a class from which we instantiate objects. And then we have some other class down here, class myapp, which uses the triangle class. So this is a class that you use, that you instantiate objects from, and this is the driver code for it. The driver code is just wherever your main normally is, or if you're creating a WPF application, it's just in whatever method, you know, that got created when you clicked on the button or whatever. So in this language, everything is an object. That's not true of Java, where you have primitive data types like ints and floats and doubles and things like that. In this language, even those things are objects. An object is an instantiation of a class. That's what I said here. Excuse me, I called it an instance. I didn't use the long enough word, did I? Yeah, I'm going to leave it. The object is the instance of the class. And then so the variables, they can also be called fields. Those are the attributes of the class. And so they comprise the data components of a class. And so these things have 20,000 different names in different programming languages. Instance variables are a very good term. You'll see that in a lot of Java reference books. The term field is kind of more specific to C#, but a lot of other textbooks use that as well. They just mean the same thing. Fields are part of the class, but I'm usually probably going to call them instance variables unless I'm talking about something very specific. But when the textbook is calling them fields, I'll roll with it. So we have our triangle class. It's got two attributes. It's got a height and a base. Like what if you had a block? You wanted to make a block class. Well, a block doesn't only just have two pieces of data. It has a height and a width and a depth. So we could declare three. Double height, width, depth. Right. It has three instance variables. How about a two-dimensional point? You know, like an XY. So class XY point. And it's got two values. It's got something on the x-axis, and it's got something on the y-axis. So down here, oh, I didn't finish this. We have get area here. When we created our triangle, we had to set its base and its height, and then we could call get area, and we could do something with it. So double, you know, area is equal to t1.getArea. So t1.getArea, our object variable, our reference variable is t1. We have set two attributes of that variable. We have set its base and its height, and then we have called the getArea method of that variable. A method is just a function that's attached to a class, so it would run up here, and it would calculate the result by multiplying 10 by 20 and getting the return value, which we can, you know, print out or do something with. So if we were going to create a class, a block, it might look something like this. Block B is equal to new block, and then we might set, you know, B dot height equal to 10, B dot, you know, width equal to 5, whatever. B dot, you know, depth is equal to 8, like that. The block carries those pieces of data. The point, I'm not sure if I like XY point. How about point XY? Because you could also have a 3D point, right? A point XYZ. But anyways, and then when you were going to make a point, you could do point P1 equals new point. And forget it. I'm just going to make a point because I keep forgetting to type the XY. There we go. Point P1 is equal to new point. And so then you would say P1 dot X equals 10 and B2 dot X, P1 dot Y is equal to negative 10, right? On whatever coordinate system we're talking about. If we want, we could create more points. You know, we're going to create a second point now. Point P2 is equal to new point. And then P2 dot X is something else. It's 1, and P2 dot Y is equal to 20, right? So we have 2 point objects, each one with their own instance variables, with their own pieces of data. The collective of all of that data is called the state. The state of the P1 object is for X to be 10 and Y be negative 10. The state of the P2 object is for X to be 1 and Y to be 20. So they have different states because they have different values in them. Fancy word. And the state of our triangle object that we made down here we gave it a base and a height 20. So this is a function that's part of the class. It uses these attributes, these instance variables, these fields. Got to have a lot of names for them. I'm going to call them instance variables until the book tells me not to. And this is a method. So an instance variable holds the data components of the class that differ for every object. Every triangle you make may have a different height than a different base. Every circle you make may have a different radius. Every square you make may have it. This sounds like a police song. Every breath you take, anyways, yeah. All the pieces of information that differ on an object, right? Every home has a different address. So in your home class, you might have an address field, an address instance variable. So an instance method is a method that interacts with that instance data. And every instance of the class has the same methods, right? So just because I made 2 points here, up here, in my little comment, if I had any methods, they would be shared by both points. So void dummy, whatever, and I don't know what this method's going to do. How about we call it init? And we set x equal to 0, and we set y equal to 0 if we call the init function. So down here, when I'm calling it, I'm going to take these out of comments. We're just going to pretend that that we know that this is down in some kind of main or something. We make a new point there. We make another new point there, and then we can call p1.init and set 10, -10. And we can call p2.init and set it equal to 120. And then we don't need these lines anymore. Right? We have the same results now. There's yet another way of doing this. But we have 2 different points. They both have access to that init method. And all the init method does is say, oh, wait, what am I doing? This is totally wrong. That was going to set it to 0. If I wanted to actually be able to accept 2 arguments here, I better make it accept 2 data elements up here. So since we want to be able to pass in 2 pieces of data, int x, int y, and we're going to have to make this look a little bit different to get that to work. We're going to say this dot x equals x, and this dot y equals y. Now, why did I use this keyword? Because I needed to differentiate whether x referred to that or that. If I just did this, like if I had x is equal to 100, and I didn't prefix it with this reference, then it'd go, okay, x is 100, and it would just change that one. And our instance data, our instance variables would remain unchanged. But if I do this dot x, then that actually does get the value 100. And so since we have 2 things called x, since we have parameters called x, and we have instance variables called x, then I'm using this keyword to differentiate between the 2. If you've done Java, you may remember the idea of getters and setters. Here's what a setter for x might look like. Void set x. And it's going to take here I'm making everything take ints, and these were declared as doubles. Just roll with it. Tell you what. Yeah. That makes it look good. Okay, so there we go. And then in here, when we call set x, this dot x is equal to the x that was passed in. So down here, I could do that. I could make a point and set its x value to whatever, right? p1.setx is equal to 100. And after that happened, p1's x value would be 100. So that's a setter, technically known as a mutator. And you can provide getters. The idea behind providing getters and setters is that you can make your data private. You can add a keyword that says, okay, these pieces of data are private. You're not able to access them directly from main or any other code. Only methods inside my class can access them. And the reason you do that is because by making your data private, you can do what's known as encapsulation. You encapsulate it like putting something in a capsule. It's got a protective shell around it, and you can make sure that the data is always good. And what do I mean by that? In our triangle class, what if we never want the base of a triangle to be 0, right? If you have a triangle and its base is 0, it's not really a triangle, is it? Or if it's got a height of a 0, it's not really a triangle, is it? So we might want to make these variables private, and then the only way they can be changed is with setters within the triangle class. And the setter could validate. Nope, you tried to set it to 0, I'm not going to let you do that. And so we could maintain valid data by doing that. Class client or class user. I was calling them drivers. I forgot that this book called them the client class. I like that term better, actually. The client class is the class that uses the class you've just written. So we have a class called triangle, and then we would have a client class. The client class is the one that creates and uses those triangles. Let's go and actually make a class. I'm going to launch Visual Studio. Looks like I've already got it. I'll erase you. Alrighty. File, new project. Not going to make it hard, not going to make it a WPF. We're just going to make it a console app. Are we on lecture T?
Yep.
I already have a lecture T, so I'm making it would have a slightly different name, but you can call yours lecture T. Okay. So everything in this file is in the lecture T2 namespace. Now, if you've taken Java, you remember that the name of the class has to mention the name of the file. That's not true in this language. You create a file name, like lecture T2, and then you can call your class anything that you want to. So we have this main class here. Let's go ahead and make that triangle class that I was playing with. Program is our client class, as it's going to use our triangle class. So class triangle.
We did that above there.
Yeah, it has to be outside of this other class definition. So double height, comma width, no, double height, comma base. It doesn't like the word base. That's a key word in C#. I'm going to go with width. All right. And so, let's provide some setters for those guys. Void set width, like that with a capital W, int W, and we're going to say that this dot width equals W. And then void set height, int H, and this dot height equals H. Now, more commonly, I would actually make this the whole word width, right? But we're going to add a little bit of error handling. If they set the width of the height equal to 0, we're going to set it to 1. So how about this? If, parentheses, W equals 0, then this dot width equals 1, else this dot width equals W. Just kind of showing the idea that your setters can guarantee that it's in a valid state. We've decided that height and width must not be 0. So if they try to set it to something that's 0, now really we ought to print some kind of error message or something indicating that, you know, that we did a boo-boo. But I'm going to leave that alone. Maybe I'll add a comment here. Maybe I will add the error message. So I'm going to put a opening brace there, a closing brace there, and then I'm going to type CW and hit tab because I'm going to print something. CW tab, shortcut for saying console.writeLine. Like that. And I should really add the same kind of thing to the set height as well, but I think that this demonstrates the idea. Where's my mouse? Then we're also going to need the set height one. And I could add this error handling here, but I'm just going to leave it alone because we already have the idea. Got that one. So you got set width, you need to add the set height. So after that curly brace. Yep, so after that one. I'm going to minimize that. Minimize that. Alrighty. So here, in main, let's make a triangle. Triangle T1 equals new triangle. And I can do this. I can say T1 dot width equals 0. However, I actually cannot. Why? The data is private by default. That's the difference between this language and Java, and I actually forgot that, is that the variables, the instance variables, are private by default. We can make them public, though. I'm going to make them public, and then I'm going to undo that change, but I would like to be able to get that line of code to compile. So I'm going to come up here where it says double height and width. I'm going to make it say public double. I just added that keyword inside our triangle class. Public double height width. These zero reference indicators sure do take up a lot of space on the screen. Oh well. And so now that I've got that, I can actually change the values directly, right? I can set T1 width equal to 0, even though I wrote this whole big old long function trying to make sure that T1 was never equal to 0. Excuse me, that the width was never equal to 0. But the silly programmer, me in this case, was able to set it into an invalid state because we had direct access to the variables, to the instance variables. That's why you make them private. So we're going to come up here and we're going to make that say private, and this is going to be an error here. Now, it's not going to let us do that. For our code to be able to call set width and set height, those need to be public. So I'm going to go and add the word public in front of our two methods here. And it doesn't matter whether they're expanded or not, right? I'm going to come up to in front of void set width and add the word public. And I'm going to do the same thing down for set height. Public void set height. If you've done both C++ and Java, this is far, This is closer to the Java syntax. Remember in C++ you could just do public colon and then everything after that was all public. Now, we're going to do it for each data element. All right, now I'm going to minimize those again. All right, so I have to fix this, but I have a method that I can call that allows us to change the width. T1.width, or excuse me, T1.setWidth equals 10. And T1.setHeight equals 20. What am I doing? These are actually function methods, right? I was getting ahead of myself. These are methods, and so when I call a method, what am I going to need to do? He wants parentheses and then a value between the parentheses. I'm morbidly embarrassed that I did that. Here we go. T1.setWidth parentheses 10 and T1.setHeight parentheses 20. And let's go ahead and write that method that will calculate the area of the triangle, which is 1/2 times space times height. Now, if we were really cool, we would go and add something to the class called a constructor so that when I wanted to make a triangle, I could say this. Don't type this because I'm going to undo it. New triangle 10, 20, and that would create the triangle and already set its width and height to 10 and 20, right? But we're not going to do that yet. We're not going to muck up our class with too many things, but I do want to get area because I want to be able to do this, right? Double area equals T1.getArea. And then I want to be able to print that out, right? Console dot, or excuse me, CW tab. No, that didn't work. Let me try that again. CW tab. All right, and then I can print out the area. Area of triangle is %. Oh wait, almost slipped into Java there. So area of triangle is placeholder 0, end quote, comma, area, end parentheses, semicolon. Now this isn't going to work because we haven't written that method, but that's how I want it to work. So we will go up and we will add a getArea method to our class. So our class is getting kind of hard to follow. Not really. I mean, it's very short, right? One thing I like to do is to add a comment on the closing brace of the class so that I know exactly what I'm looking at, and then as I add new members to it, I make sure I add it above that curly brace. So for my triangle class, on the closing brace of it, I'm going to do end class triangle. You know, that doesn't change the way the program works. It just tells me that that's the end of the class, and the reason I need to know that is because I'm going to add a getArea method. So public double getArea, parentheses, end parentheses, curly brace. So double result equals this dot height times this dot width divided by 2, and then return result. I'm going to run it, make sure it works, and then I'll pause. Oh, I don't have my get key at the bottom, do I? I'm going to go down to the bottom of main. I'm going to add a comment here for that purposes too. End main. So console.read key. All right, you've seen that I added that above main. Now I'm going to go back up in case you still need this code right here. Try it out. Yep, the area of that triangle is 100. Sure, sounds good to me. So that's where our method is declared, right there. So down here in main is where we're going to use it. So I'm going to go down to main, and there is the code where I actually call the method that I just wrote.
Okay, I see.
And although we didn't do it yet, since we have setters, we should also have getters, right? Our triangle class is not complete because there's no way for this thing down here to know what the width and the height are, other than the fact that we can look up there and see that it's 10 and 20. So we should come up here and we should add getters and setters to our triangle class. But I'm going to skip that because we're going to do that for the next class we're going to make, which is a circle class. So let's go down here to class program. Just push that down, and then do class circle. And every circle has to have a radius, so double radius. I'm going to make that private, although by default it already is. Private double radius. And I'm going to add a getter and a setter for it. So public void set radius, parentheses, double space r, and so this dot radius equals r. But we need a getter too, one that'll return the value of the radius. Public. Now I can't make it void because it's actually supposed to return the radius. And what type is the radius defined as? It's defined as double. So public double get radius. And we're not passing anything in because we're getting the value out. And then return this dot radius. Now that's the Java way of doing it. If you've done a couple semesters of Java, then you've seen that a lot. The Python way of doing it, if you've done object-oriented programming in Python. C# has something a little bit different, which lets you write getters and setters that don't look like they are getters and setters, and I'll show you what I mean. But first, so some people won't use the this reference when it's not necessary. I didn't have to put this there. I didn't have to put this there. The only time you have to use the this reference is when you're making sure that you're distinguishing between a local variable and the instance variable of the same name. However, I really like being able to type this dot and getting a list, right, of all the variable members in there, and that way if the thing has 20 different variables in it, then it's easy for me to get a hold of them like that. So you'll see me use this dot every single time. Another thing that I will do is just to tidy things up a little bit. Sometimes I'll make the getters and the setters take only one line, and I'll show you what I mean, just like that. Because if that's all it's doing, if it's not doing anything complicated, right, it's not checking values or forbidding negative values or anything, then that's enough, right? So down in main, we could create a circle, and we could set its radius, or we could get its radius. So circle C1 equals new circle. And now let's set its radius. So C1 dot set radius to 20. And then later on, if something changed it, we don't know what may have changed it or whatever, let's print out the radius of it. So console dot right line parentheses radius is placeholder 0 end quote comma C1 dot get radius. And that's a perfectly valid way of programming, and that's the way you would see it written in a million Java programs. But C# gives you the ability to do something a little bit different. You can use fields that mimic the appearance of public instance variables. Because wouldn't it be nice if when I want to get a hold of the radius, I could just do this, C1.rad, don't type this is going to be an error, right? C1 dot radius equals tip, right? And then when I wanted to print it out, I could print C1 dot radius. But when I did that, it did whatever error checking I wanted set radius to do, like forbid 0 values. Now we didn't make it do that, but we could, right? We could come up here and we could modify our code for set radius so that it would forbid 0 values. Negative values or something like that. We may as well do that. Nah, we're not, but you know the idea, right? If you use the setter, then it can do any kind of error checking it needs to do to make sure that the instance variables are in a valid state. So we can do that. We could make a class where we can access the private data as though it were public data, but it's still going through the getter and the setter. And so let's make a Circle2 class, a new improved Circle class. So class Circle2, it's still going to have one instance member, instance variable, private double radius. But then we're going to add some methods with getters and setters like this. Public double radius with a capital R. Open brace. Get return this dot radius lowercase r. And set this dot radius equals value. And I'm getting syntax errors. I'm not supposed to put a semicolon there, excuse me. All right. They need to be inside the braces. That was the problem. Okay. See, I was getting fancy typing them all on one line of code, and it caused me to put my semicolons in the wrong place. And we're going to add a couple print statements here just to prove something. To prove that the getter and the setter are being called. So here above, inside the get method for that field, we're going to do console dot write line. I am setting the radius. And then just do the same thing for the getting, right? Console.WriteLine, I am getting the radius. That's just to prove that that way we can see the methods being called. And this is the end of our Circle 2 class. End Circle 2 class. All right, so if you have used Java, you're recognizing that this looks pretty dang weird. That does not look like a method, right? That does not look like a method. And here's this miraculous variable coming out of nowhere, right? This value. Where'd that word come from? Compare the way this looks to our other class. Come up here, and I'm going to pad this out like that, back to the way it should be. Here's the set radius as we implemented it in the old Circle class. Suppose we had called that value. There. So this is what that looks like. I'm going to copy that. Don't do this. Don't make this change. And I'm going to paste it above right here so you can see the difference between the two. And it's going to give me errors all over the place because it's not valid syntax. But we have our setter. This is just letting us get rid of some of the fluffy syntax. We don't need public. We don't need void. All we need is the word set. And we don't need that. And we don't need to call it value. And then once we deleted all that stuff, then it looks the same. Right. So this is just a shortcut for writing this. And the get is just a shortcut for writing the get radius function. Right. So, but what's cool about it is, let's go down back to where we created our circle. Here we go. And let's make a new circle, but it's of the new class. So circle 2, C2 equals new circle 2, parentheses in, parentheses, semicolon. And then C2 dot radius equals 20. And then let's print it out. Console dot write line radius of C2 is curly brace 0 end curly brace end quote comma C2 dot radius. Need to check something. So if we compare the two, when we wanted to change the radius here, we had to call set radius. That was our setter. Here we just accessed it as though it were an instance variable, as though it were a public instance variable, but it's really not. This is what's known as a property. In C# you have instance variables and you have properties. The instance variables are the ones that you declare, public int x and public int y and and things like that. But the properties are the ones that you define with the little get word and the little set word. Those are your getters and your setters. And the general rule of thumb, although it's not a law, is that you label your instance variables with lowercase letters and you label your properties with uppercase letters. So that's why inside our circle class, we had an instance variable called radius, and so we declared it as double space radius with a lowercase r. But then we declared the property with an uppercase r. All right, gang, something weird going on. I always make my classes with uppercase letters, and this time I didn't. So if you're getting an error typing this, that's why. I need to go back up. I'm going to find my Circle 2 class and make it uppercase. Then I'm going to have to go back down here and change these to uppercase C's. Okay, so when we run it, Well, let's go back and look at our Circle 2 class again. Here's our Circle 2 class again. This is the instance variable, and this is the property. The property is kind of like the public spokesperson for this private piece of data, right? And so when we want to access this private piece of data, if we're trying to get it, it calls this one. And so we're going to see a message that says, I am setting the radius. And then when we try to set it, the public spokesman, the setter for the property is going to say, I am getting the radius. Wait, I've got those reversed, right? Getting, yeah, all right. And then I am setting the radius. Okay, so when I run it, I'm going to see these things get called. I'm going to see that right line message come up, and I'm going to see that right line message get set up. And so, yeah, here it is. I am setting the radius. I am getting the radius. And what's weird is that down in the main code, it doesn't look like we're doing that, right? All I'm doing is that. And that printed out the message, I am setting the radius. Because when we say C2.R radius is equal to something, it comes up to that property. And it calls what? There. And the property has a getter and the property has a setter. And so when we try to access it as though it were an instance variable, if we're trying to assign it a value, it calls the setter method automatically. And if we're trying to retrieve the value, it calls the getter method automatically. And if you want to make it a read-only property, you just comment that out, right? Yeah, you delete the setter. They can't change it, but they can get the value of it. So properties are pretty cool. Instance variables versus properties. The syntax of the property is a lot longer than it is for declaring an instance variable, isn't it? Yeah, but it lets us not have to type in the get radius and the set radius. And was that much more typing than we had to do here? Not really, but it allows ourselves or somebody else to access the instance variable as though we were accessing it directly, C2.radius. But it's still calling our function, and we could still validate the data. We could put some code in here that would throw an error message if they tried to set it equal to 0. So C2 radius is equal to 0. We're going to come up here, and we're going to write our code to forbid setting it to 0. So if value equals 0, we're going to print out our error message. Console.writeLine cannot be set to 0, so setting to 1. And we're just going to say value is equal to 1. So now that my setter has this error checking in it, if I go down here in main to where I was setting the radius, if I set it to 10, I'm not going to see that error message. I am setting the radius. Okay, great. But if I change it to 0, then that's the error state and it's correcting it. Cannot be set to 0, so I'm setting it to 1. So there's proof positive that even though we're treating it like it's a variable, right, it's really not. Now in C++, to be technical, there is the idea of overriding the assignment operator. And you can do the same thing with overriding the assignment operator. C# does not strictly let you override all the operators like that, but then this getter and this setter are, in effect, overriding the assignment operator.
I'm not getting anything.
So that's it for today. I wanted you to have the idea of getters and setters, which you've probably seen in other languages, and I wanted you to see the way that you do them in this language when you implement them as properties. And you can find that in the PowerPoint, excuse me, on the pages where it starts talking about properties. on page 16. A property is a member of a class that provides access to the field of the class. Field being the instance variable. And the property defines how the fields can be set and retrieved. Every property has accessors. You can have a set accessor and you can have a get accessor. Now you don't have to have, a set accessor if it's going to be a read-only property. So a read-only property has only a get accessor. So you can jump ahead to page 16 and you can read the book about them if they're looking a little bit different than the syntax you've used in other languages. If you haven't used the other languages, then hey, then this all looks perfectly reasonable and same. Okay, let's stop our lecture there. So this is lecture whatever, T. Go ahead and put this in the T Dropbox.